Every major construction project in history has gone over budget. Not most of them, not the badly managed ones. Every single one. The 102 million. The Big Dig in Boston was projected at $2.6 billion and finished at $24 billion. California high-speed rail was supposed to cost $33 billion, and the estimate now sits above $100 billion with no end in sight. This is not incompetence. This is a structural feature of how construction works, baked into every contract, every bid, every schedule from day one. And once you understand why, you will never look at a project announcement the same way again. Construction projects begin with an estimate, and that estimate is almost always wrong by design. When a contractor submits a bid, they are competing against 5 or 10 other firms for the same contract. The winner is usually the lowest number. This creates an incentive to bid low, win the job, and recover the money later through change orders. A change order is a formal modification to the original contract, and they are how contractors actually make their margins. A bid that looks unprofitable on paper can become very profitable once the client starts asking for modifications, which they always do. This is called the low bid trap, and governments and private developers fall into it every decade. Some experienced owners have moved to best value procurement to combat this, but low bid contracting still dominates public construction worldwide. Labor is the single largest cost driver on any construction site, and it is also the hardest to predict. Skilled tradespeople, electricians, plumbers, ironworkers, glaziers are in limited supply in most markets. When multiple large projects compete for the same labor pool, wages rise sharply. A project budgeted for $40 per hour electricians might find itself paying $60 by the time it breaks ground, because 3 other towers started in the same city that year. Add overtime, benefits, and the productivity loss that comes with unfamiliar crews working on complex systems, and labor costs routinely run 30 to 50% above initial estimates. Workforce shortages in trades have worsened significantly over the past decade as retirements have outpaced new apprenticeships, and there is no quick fix on the horizon. Steel, concrete, copper, lumber. Every major construction material has a price that moves with global commodity markets, currency exchange rates, and shipping costs that can shift dramatically between the day a project is designed and the day materials are actually ordered. In 2021, lumber prices tripled in 12 months. Steel costs spiked 40% during supply chain disruptions. Projects locked into fixed-price contracts with suppliers before those spikes absorbed the difference themselves. Those that were not locked in paid the market rate. Long lead items like electrical switchgear and elevators can require 12 to 18-month delivery windows, meaning a delay. Anywhere in the project creates ripple effects throughout the schedule. Every idle week on site costs money that was never budgeted. Design is never finished when construction starts. Clients change their minds about layouts, finishes, systems, and structural elements continuously throughout a project. Each change creates a cascade of revisions. Move a wall, and you move the electrical conduit, the plumbing stub-outs, the HVAC ductwork, and potentially a load-bearing element that requires an engineer's review. A $10,000 design change can generate $100,000 in construction rework. The industry term for this is scope creep, and it is the reason most project managers become gray before their time. Studies suggest that design changes account for up to 40% of total cost growth on complex commercial and infrastructure projects. Building codes, environmental reviews, zoning approvals, utility coordination, historic preservation requirements, accessibility standards. Every jurisdiction layers its own requirements on top of national standards, and those requirements change. Environmental discovery, finding contaminated soil, protected species habitat, or archaeological artifacts can halt a project entirely while specialists are brought in and remediation plans are approved. These delays cost money every day the site sits idle. Equipment rentals continue. Financing charges accumulate. Workers get reassigned or leave. A 6-month permit delay on a project carrying $20 million in debt can add over $1 million in interest alone before a single foundation pour begins. Beyond market forces and technical complexity, there is a documented psychological bias called optimism bias. Decision makers consistently underestimate costs and timelines for projects they want to build. Oxford researcher Bent Fleabjerg studied hundreds of major infrastructure projects and found that cost overruns were not random errors. They were systematic, predictable, and consistent across countries, cultures, and project types. The more unique a project, the worse the overrun. Mega projects involving new technology or untested designs routinely cost double the original estimate. Politicians and executives approve optimistic numbers because realistic numbers would never get projects approved. And yet, once started, projects are almost never canceled, no matter how bad the overruns get. Reference class forecasting is one of the few approaches that actually improves accuracy. Instead of building a cost model from scratch for each project, you look at the historical outcomes of similar projects and use that distribution as your baseline. If every hospital of this size in this region has run 20% over budget, you build 20% into your plan before the first drawing is produced. Integrated project delivery, where contractors are brought into the design phase rather than hired after drawings are complete, also reduces surprises. When the people who will build a thing help design it, fewer impossible details end up in the plans and fewer change orders derail the schedule. The gap between what a construction project costs on paper and what it costs in reality is not a failure of planning. It is a product of competitive bidding, commodity volatility, design iteration, regulatory complexity, and human psychology operating exactly as they are designed to. Understanding that gap is the first step to building anything on budget. The second step is adding 30% to whatever number your contractor just gave you.